Well, I did finally get my last 5 spokes made for this Yellowstone Park stagecoach. Remember, I was 5 short, and I tried turning them out on my pattern lathe, and I did one by hand, but I haven't done. And I did some rough sanding on them. I still have to make the tenons on these. But we've had a week of mid-60s, and a couple days we got it into the 70s even. But last night we had a front come through and we ended up with 6 inches of snow. So I'm going to run out and make sure that the cows are okay. Hey girls, in and out of the snow, that's nice. Well, they're all huddled up pretty dry and cozy. They should be doing good. Nice thing about these spring storms, they don't get terrible cold. And it's really nice to have that concrete floor set up inside my pole barn that it's now going to kind of become a little more of a working shop. So that was nice to see. But I've got another little treasure, and you know, treasures are treasures, and I want to show you what it is. I don't know if any of you recognized it in the last video, but I have a new anvil here. And when I say it's new, you know these anvils are usually not very new. This is a Peter Wright. I kind of played with it a little bit and cleaned it up some, and I highlighted the stamp in here so you can read the Peter Wright patent, and then the solid isn't real clear, but the wrought is pretty clear. Solid wrought in a circle. Looking up, that was produced between 1860 and early 1900s, so somewhere in that time frame. We have a 1 and a 1 and a 14. Well, these were made in England, and the first one corresponds to 112 pounds. This is a stone weight, I guess, if I understand. The second one is a quarter stone, or a quarter hundredweight. So this would be 112 plus 28 plus 14. So you add 112 and 28 and 14, you come up that this is a 154-pound anvil. And the corners on this is so typical with so many anvils, were all beat off and broken and chipped. The back end of the heel here was chipped off as well. And the front leading down to this cutting shelf was also pretty abused. So I took some time and I rebuilt that. I weld on it and then I beat it in, weld on it, beat it in, and then faced it off. So now, nice and clean, nice face to that anvil. So you probably already know that I have two other anvils. They are both Haybudens. The one back toward my welding bench is a 160-pound anvil. That was the first anvil that I bought, I think back in 81, maybe 80, 81 in that area. And the one I have over in my blacksmithing area is also a Haybuden, and it is a 217-pound Farrier's anvil. Both of those also were beat up and abused from a lot of years. And so I refaced those. So I've been using that 160 anvil for 42, 3, 4 years, something like that. So when these have a top face that is welded onto a cast steel body, that face is fairly easy to fix up. So I used to have a Peter Wright in this exact same spot. It was a 145, and you all know that our youngest, Janelle, is our daughter, and she is a blacksmith down in Austin, Texas. So when she was getting going, I had one of these round rivet forges. I sent that down to her, and I also gave her my Peter Wright 145. And so I've kind of missed this to some degree. You know, it's not like I'm short of anvils, but it just helps save me a lot of steps when I am working around in this area and I just need to tweak something. You know, it's 30, 40 feet back to my 160, and it's another 30, 40 feet over to my 217. So when I want to just do a quick little straighten out, it's nice to have one right here. So it's nice to have Peter Wright back as well. So back to the task at hand, and that is finishing my 5 spokes, and that involves cutting the tenons on the end. Well, the tenons are a direct relationship to the dish in a wheel. And if there is one question that I am probably asked the most repeatedly is, what is dish and why is it there? So this is an original Yellowstone Park Stagecoach rear wheel. And as you look across the face of this wheel, you can see that these spokes are not straight in line across from each other, but they come out of the hub at an angle. So the reason why this is called dish is just like a dish. has an outer rim, and then it is recessed toward the center, just like a dish would be. So a few videos back, you watched me turn these hubs and then cut these mortises into the hub that are going to receive the spokes. I have one on the stand, and you can see I have the other three sitting underneath the undercarriage. So as I have this hub on the stand, the outside of the wheel is actually facing up. So the dish is going to go this direction. Now you remember me talking about that on the majority of wagon hubs, these spoke tenons all are in a line. So I would have cut these mortises all the same. But on the Stagecoach wheel, they are offset 3/8 of an inch. Well, the leading edge facing out of the wheel is cut square with the hub, but the back edge of this mortise is cut at an angle. But when it comes to cutting the tenon on the spokes, I'm only concerned about this square shoulder right here. I'm not going to be worried about the back angled one yet. So right now, I'm just going to concern myself with how do I create this dish? Not so much the why, we'll get into the why. But how do I get these spokes to come out at the right angle? So when I initially cut out these blanks for my spokes, I made them 1.25 by 1 3/4, and I made them straight. I ran them through the planer, if you remember. So then I took and I measured back 6 inches, and I started my taper from 1 3/4 down to 1.25 on this end. So the leading face of this spoke remains straight, but the back side of this spoke has a taper to it. So this spoke here would be the closest spoke to the outside of the hub. If we look straight across from one side of the wheel to the other and put a tape measure in there, we'll see that we have almost 1 inch of dish in this wheel. So the question becomes then, was it built this way initially, or did it increase in dish over time and wear? And I think the second option is the real answer. Oftentimes you'll find spokes that are not straight anymore, but you see a bend to them. And oftentimes you can see it on the leading face of these spokes as well, where they're no longer straight. And the spoke underneath this one is actually broken. But generally, when you look across from one side of the wheel to the other, you want this leading spoke to be recessed down from this flat plane, generally 3/8 of an inch. On a wheel this tall, it could go up to 1/2 an inch. So if I use the square corner of my table saw as an example of that straight square cut of the leading mortise, and if I put my leading edge of my spoke square with that mortise, you can see that my leading edge is going to come straight out from that mortise, which makes sense, right? So the leading edge of my spoke is going to follow the leading square edge of my table saw. If I cut this tenon at a 90-degree angle to this shoulder here, I would have this effect. But if I want this to be recessed back 3/8 to 1/2 of an inch, and my shoulder is going to be up here in this area, and have my spoke come out to this point here, well then this shoulder can no longer be 90 degrees. It needs to be, in this case, it needs to be 1 degree off. And it'll give me this effect. But then if my second mortise is 3/8 of an inch offset from my leading mortise, then my second spoke has to be here, but I want the end of the tenon to come out to the same spot on the rim or the felloes. Well, then I have to increase the angle of this shoulder for the secondary spokes, and I would end up with this effect. So if I allow a 1/2 inch on my first spoke and 3/8 on my second spoke, I'm going to cut this shoulder at 1 degree for the leading spoke, and I'm going to cut the second one at 1.5 degrees. And that is the advantage of having these degree markings cast right into my table saw table, because each degree is about 1/4 of an inch apart. So if I start out at my 0 and I want to go 1 degree, I can also split these degrees and I can go to my 1.5 degrees. So if I go back to these 2 spokes that we have stacked up, the leading edge is going to have 1/2 inch of dish, but the secondary spoke is going to add another 3/8 of an inch, so this spoke is going to have 7/8 of an inch dish. And they're going to stagger. One's going to be 1/2, one's going to be 7/8. One will be 1/2, one will be 7/8. So we end up with kind of a compound triangulation. We have a triangulation effect just in the building of the body itself, and then we have a triangulation in the dish from 0 to 1/2 inch, and then we increase that to 0 to 7/8 of an inch. So we're creating little triangles through each spoke. One is 0 to 1/2, one is 0 to 7/8. And I also think you can see it if I lay it down on my table saw here. This is the leading edge, and if I push down on the bottom here, the spoke stays pretty straight. But if I turn it around, then you can see the triangle effect that we have created. From 0, now we have that triangle. And we should be at 1.75 inches on that end. So the second issue about dish, past how do I create it, the question is, why do I create it? And it has to do with the load capacity on the wagon or the buggy or the stagecoach, and how steep a hill you're on or how fast you turn your corners. Because as you turn your corner or you are on your side hill, the weight of that carriage is carried on the axle, pushing into that wheel on the hub. And if that wheel was flat with enough weight, that axle would just push its way right through the wheel, and it would collapse the wheel. And maybe one way to demonstrate that is I have a paper filter for paint. They're fairly flimsy, and I'm just going to curl these edges in, and the ends just are fine mesh for filtering paint, and I'm just going to push that down out of the way. So it's going to sit like so, and I'll show you what I mean. So they're fairly flimsy. See this mesh here, just for straining paint, there's no strength in that mesh, so I'm just going to get rid of that. And this is an extreme dish scenario. Paper by itself is pretty flimsy, but now this paper in the form of a dish can hold a lot of weight because of the shape of the cone. And that's what's happening on a carriage or a wagon or a stagecoach. This is representing the axle and the weight of the carriage. This is representing the dish and the wheel, and the downward pressure is the same as the side thrust on that wheel. And this thin little piece of paper is able to carry something much heavier than even the strength in that wheel. And that is the principle of dish in the wheel, why these spokes have to come out at an angle. You know, the spokes go in individually, the felloes go on in either 2-spoke sections, or in this case, we're going to put them in halves. But there needs to be something that ties all this together that actually gives it strength, and that's why we put on a metal band called the tire. It's what ties the whole wheel together, and that's what all these spokes and the felloes push against. when the side thrust into that hub is pushing on all this wood, it's actually being transferred out to the tire that holds it all together. And that is also why the basic fundamentals are why you don't drive wagons, buggies, stagecoaches, carriages with tires that are loose. Because when that side thrust goes into that hub, it is able to move all that wood until it hits the tire. And all that movement, give and release, it's just back and forth, back and forth, back and forth, and it works all those joints loose until it hits that tire and is told to stop. When that tire is tight, it has to stop immediately. So don't run your wheels with loose tires. So now it's the how to do what I just all talked about. This is the leading edge of the spoke. This is going to be going directly into the hub as if it was square, but I want this to come forward that 1 degree. So I'm going to back this off 1 degree. Right there. That's going to give me that dish right there. Well, this is only going to allow me to cut one side of the tenon using a table saw. To do the other side, I have to rotate this spoke to go this direction. Well, now I'm no longer working on a straight face, but that's why I came back 6 inches and left this straight. So if I move my fence now to 1 degree the other direction, but I keep this portion of the spoke against my fence and I don't pay attention to this section, then I'm going to show contact here, but this spoke is actually going to not touch my fence down here, but I can still get my 1 degree to this face, just because I left my 6 inches here straight. Now, this is not how they would have done it back in the day when it was mass production and speed was of the essence. They had machines that you could just a single pass through and it would take both of them at once. This is slow, but it works for me for 5 spokes. And for these 5 spokes, I'm going to do them all the same, 1 degree from my leading face. When I measure the other spokes that I have that are already factory made, they are also at 1 degree. This is the straight leading edge. If I put a square on that, you can see that 1 degree off. So as I go through the process of actually assembling these spokes into the hub, I'm going to do all those leading spokes first. They'll all be the 1 degree, and then I'm going to have to adjust the secondary spokes to my 1.5 degrees, even on all these factory made spokes. These spokes were made for hubs that the spokes are all in a line. When I'm staggering them, then I have to make that adjustment. I have done it where I have not made that adjustment, and the secondary spoke, I can just pull it into place, and when I set that tire, that 1/2 degree will actually just be compressed into the wood of the hub. So you can force it, but why not just make it right to begin with? So I'm just going to mock up an edge here. I'm going to clamp a board square with the end of my table saw and double check the angle of my shoulders. This is the first spoke I did at 1 degree. This is the second spoke I did at 1.5 degrees. So if I shoulder that up right there, I have my 1/2 inch there, and I'm zeroed out there. I'll try my 1.5 degrees. Zeroed out right there. Just feeling this tightness in my shoulder. And I'm at 7/8. So those two angles are going to work. Well, that is a rather extensive explanation of why dish is in a wheel and how do you put it in there. As regarding stagecoach wheels, the fundamentals are the same whether it is a buggy wheel or a wagon wheel or a stagecoach wheel. But the principle of dish, I hope you understand. It's been snowing all day, and it was kind of fun to share about my new anvil. That's kind of a guy thing, huh? Anyway, I just have a few more tenons to cut. We'll start putting spokes in. Appreciate you coming along. Thanks for watching.